Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
My dear wonderful students of Senior 3 Chemistry, I'm very sure you are very fine. I'm also very fine. And I just want to invite you to this lesson number 2 of Unit 9. You remember we had talked about the lesson number 1 where we talked about the alkenes. I hope you still remember. So this time around, in lesson number 2, we'll be talking about the alcohols. Remember, the Unit 9 is talking about the structure and properties of alkenes and alcohols. So under the structure, we are going to look at, when we go to the alcohols, to be precise, we look at the structure of the alcohols, we look at the methods of preparation, we look at the nomenclature, that is the system of the naming of the different alcohols, we look at the physical properties, and then mention some uses. That is our lesson of today. So please, I want to invite you to get ready with your pens and book so that you can write down some information that you refer to at a later time, if need be. And I hope that information will be very important that you will write down. So let's go. So we look at what are the alcohols? When we talk about the alcohols, what are they? So these alcohols, they are a group of family of compounds, a group of organic compounds, I beg your pardon, a group of organic compounds, like a family of the compounds, like we looked at the alkanes, we looked at the alkenes, and now we are looking at the alcohols. Those are the families which we refer to as homologous series. So when we talk about the alcohols, so they form another family or homologous series. Homologous series. So we'll be talking about the homologous series of alcohols, or family. We can just mention the word family. So it is a family or group of compounds with the same functional group. You remember the functional group for alkenes? I'm sure you do. The double bond, we said the double bonds in alkenes act as a functional group. So these compounds, in their structure, they have this compound. They have, rather, this group of atoms, OH, in their structure. So when you look at the structure of any organic compound, and you find that there is this OH, then know that this is the functional group. So this is the hydroxide. We can sometimes call it hydroxyl group. That is what it is commonly known, hydroxyl group. So with the OH in those all the compounds. So that is the functional group. You remember what we talked about the functional group? We said a functional group can be a double bond, or can be a triple bond, or an atom, or group of atoms that determine the chemical behavior of a certain group of compounds, a certain homologous series of compounds. So this is the OH that will determine the chemical behavior of these compounds. So these compounds are represented by the general formula. By the general formula, you remember the general formula for alkenes. For alkanes, you should always recall all those, because those are very important part. The moment you have the formula, the general formula, then you can easily write the structure of those compounds. So they have the general formula CnH2n plus 1 OH. That is all the compounds. That is all the compounds of alcohols that we are just going to look at. They are represented by this general formula. So this is a just bit of the introduction that we all need to know. Now, we can move on and talk about the nomenclature and the structure. They will all be together. Nomenclature and structure. Nomenclature is the naming of these compounds. Naming. When we talk about the nomenclature, it is the system of naming. And this system of naming is international, remember. It is international. So that is why we call it IUPAC system. You remember that? IUPAC system. This is U. International Union of Pure and Applied Chemistry. So that is a union. So whenever we name the compound, we are naming the compound according to this. Because it is internationally, so that we don't have our own chemistry. Because chemistry is the same all over the world. That's why it is this. That's why we use that system of naming the compounds. So let's move on. These compounds are named from alkanes. They are derived from alkanes. How? How are they derived from alkanes? When an alkane, for example, the first member of the alkanes is called methane. Methane. So how do we write the structure? The structure of the methane is CH4. That is the member. So when one hydrogen is replaced by the OH, remove one hydrogen here and you replace it with OH. So that means you will have, this is an alkane, this is an alkane, and then you have the alcohol. So this one will become CH3OH. That is how they are derived from alkanes. One hydrogen. If you have ethene, not ethene, ethane is C2H5, H6. That is ethane. That is an alkane. So you need an alcohol that is derived from this alkane. Remove one hydrogen here. So when you remove one hydrogen, you have C2H5OH. Then let's take it with the naming. We said this is methane. So what we do, we just remove this E of the alkane and replace it with all. So this one becomes now methanol. So that will be the suffix that is added, methanol. So the suffix that is added there is or. So they all alcohols. That's why they are called alcohols, actually. They have the same naming with the suffix. They all end with or, alcohol. Methanol. This is ethane. So remove this E and replace it with OH. So you replace it with OR. Sorry? So this one becomes ethanol. You have others. You may have propane. Propane is C3H8. Now, if you want propanol from there, then you'll have C3H7OH, and this one will become propanol. Propanol, and so on. So this is the system of name. You know, when we are naming these compounds, these alcohols, especially when you come to carbon number 3, this is something that is very important. When we come to carbon number 3, we have what we call the common names, and then we have the international names, the IUPAC names. So when we are naming compounds, there is sometimes we use the common names, and at one time we use IUPA names. But the IUPAC names are the ones which are accepted chemically and internationally. Let's look at the screen and we look at the names that we are using. So you look at we have methanol, that is number one. Methanol here, it is methyl alcohol. It is methyl alcohol. Methyl is this. This is a methyl group, remember? This is an ethyl group, and this is the propyl. This one will be propyl group. So the propyl, that's why we call it some propyl alcohol and so on. Those are common names. Then we have these two compounds here. We have propan-1-or and propan-2-or. Very important. CH3, CH2, CH2OH. This is the same as this one, and this one are the same. 3 carbon atoms, hydrogens, and then OH. Then we have this CH3C, then we have OH, CH3. When you look at these compounds have the same number of carbon atoms, have the same number of hydrogen atoms, but the arrangement and the position of the OH are different. This is on position number 1. If you remember how the alcohols are named, this is position number 1, number 2, number 3. This can be 1, 2, 3, and so on. So that is why, because of its position, this one is called propan-1-or. And whereas this one can also be called 1-propanol. 1-propanol. So this one becomes propan-2-or. 2 is coming from where? The OH is attached on carbon number 2. The OH here is attached on carbon number 1. So that is where we are getting those numbers. So that is the structure and the names. The structure and the names according to that. So we may have another one. Maybe if we have CH3, CH, maybe we have CH3, we may have even a branch, CH3, like this. So what you do, you need to choose the longest chain. The rules of naming alkanes still apply even in other compounds. So you choose the longest chain, number 1, number 2, number 3. So when you look at this compound, the base name will be propane, but it has the branch on carbon number 2. This is one branch, and this one is also another branch, which is OH, the functional group. So what do we do? So it will be 2-methyl. 2-methyl, if you remember the rules of naming the alkanes, then this one becomes very simple. 2-methyl, propan-2-or. Or you can say, this one can also be written as 2-methyl, 2-propanol. 2-propanol, like that. So that is the naming as it is required. So we look at the preparation. Ethanol is a very important chemical. If you recall, in all this period of the pandemic, the COVID-19, we have been using ethanol as an antiseptic that kills the virus. So it is very important. So that is why we look at the uses. That one, maybe we'll discuss it later. So let's look at the first, how is the methanol, among other alcohols, how is ethanol prepared? So there are 2 methods here that are employed in preparing ethanol. That is on large scale, not not in the laboratory. So we have the hydration of ethene. Hydration, remember, it is addition of water. And then we have fermentation of glucose. So all foods that contain starch, the cassava, the potatoes, the Irish potatoes, the rice, the maize, and whatever, all those, you can just name them. All those foods, all those substances can be fermented to produce ethanol. So we have hydration. We look at there are two methods, remember, fermentation of glucose and hydration of ethene. So we have, in hydration, this process takes place in presence of a catalyst. The catalyst is the acid that is used. You can just look at it over there. So we have the catalyst, which is phosphoric acid. And then the temperatures must be specific, 330, and then you have the atmospheres of pressure. This must be, that makes this very expensive. Those are high temperatures and pressure, so those must increase the costs. But this is large-scale production. So we can look at the reaction. That is the reaction where, this is the hydration reaction, where you have ethene plus water. This is phosphoric acid. The temperatures are between 300 to 330, 60 atmospheres of pressure, and then you produce ethanol. So those temperatures are very, very important conditions for the reaction. Let's proceed and look at the fermentation. We'll just go through very fast. We look at the fermentation of the sugars. You remember I said substances that contain starch, any food component that contains starch can be used to produce alcohol. So you can't say, I don't have this and that. So you can use any food that contains starch. Maize, potatoes, the Irish and sweet ones. You can use the sugar cane. That is the most commonly used. So during the fermentation of sugar, starch is dissolved in water and yeast is added. That is an enzyme, so that is acting as a catalyst. The mixture is then fermented between 15 to 35 degrees Celsius with the absence of oxygen. So it is anaerobic respiration. It takes place in absence of the oxygen. So the temperatures must be between this, because beyond the high temperatures, the enzymes are denatured. So that is why the temperatures have to be controlled. Yeast contains the enzyme. I've already mentioned that. And I said high temperatures will can denature or can destroy the action of the enzyme. Yeast respire anaerobically. I mentioned that this process does not take place in the presence of oxygen, because yeast respires anaerobically. It is anaerobic respiration. It takes place without the oxygen. So that is the reaction. You have the glucose combining with the enzyme, which is we said yeast. It produces carbon dioxide and ethanol. The yeast are killed off once the concentration, so the concentration of alcohol also kills the ethanol. So what does that mean? It means that the reaction has to be restarted again and again. So you remove the contents of the products and then replace them with other new contents. So the reaction is not a continuous process. We'll look at that one later. Fermentation is anaerobic. We have already mentioned that one. We don't need to mention it. And we have mentioned about how the percentage, the concentration of the alcohol in the solution also destroys the yeast. And that is why the contents, the raw materials have to be repressed from time to time. It is non-continuous process. Fractional distillation can also be used. So it has to be distilled. And when you distill, then you get the higher concentration of the alcohols. That is either brandy, you have whisks, you have wines. Those are highly concentrated because of the distillation. You have vodka, you have all that stuff of the types of beers or alcohols that contains ethanol. So we look at the difference between these two processes. We have hydration, and then we have fermentation. Hydration, as I mentioned, it is a complex process, a complex setup required because it is even expensive. But the fermentation, this one can be even done in home. In homes, that is very possible. Uses non-renewable resources, non-renewable. Substances cannot be regrown. They are not renewable. They cannot be regrown. They are used and finished off. But for the fermentation, the raw materials are renewable. When you use sugar, you can grow as more sugar, potatoes, maize, and so on. Those are renewable substances. That's what makes fermentation process a bit simpler and cheaper. Continuous process, and therefore, this one which is continuous is more effective than the other one which is the batch. The batch, because of so many components in it, then it is removed and the reaction is restarted many times, and that makes it inefficient. It is very fast, the hydration is very fast, and this one is very slow because the fermentation can take even a week, and therefore you have to consider that one. And many other, so you can look at them, raw temperatures, high temperatures. You have carbon dioxide, which is a greenhouse, no carbon dioxide here. So we are comparing which one is the best to use. But remember, those are all industrial processes. So we talk about the physical properties. Physical state and order. Alcohols exist as liquids. I think you have never seen alcohol in a solid form. If they exist, they are those ones with very high molecular masses. So they exist with a distinct order. A distinct order, a very unique characteristic order. So it is not, the smell is different from other liquids. Solubility, they are very soluble in water. They dissolve in water. And they also dissolve in other organic compounds. They are non-conductors. They don't conduct electricity at all, and they are very neutral to litmus paper. They are like water. They are neither acidic nor basic. So those are some of the physical properties. And the boiling point will depend on the mass. It will depend on the mass, the molecular mass of the substance. The mass goes with the number of carbon atoms. As we can see in the table here, the table is summarizing for us. It is talking about these are alcohols, the melting points, the boiling points, the densities are also increasing, the solubility is also decreasing. As the number of carbon atoms decreases, the solubility, as the number of carbon atoms increases, the solubility decreases. That is something very important that you should know. So that is why we have soluble, 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 fairly soluble, fairly soluble. So as you go down, you will have insoluble. That is what we are mentioning now. The boiling point also in that order. As the carbon atoms increases, the boiling point will also increase in that order. So you should always remember that the boiling points, the melting points, the density are increased, the boiling points and the melting points and density are increasing, whereas the solubility is decreasing, depending on that. So things that you need to remember that we have talked about. You need to remember the functional group of these alcohols. You need to remember the general formula of these compounds, and then you need to remember how these compounds are named. Remember, we have said that they all have the same functional group, which is OH as the functional group. Remember the methods of preparation. We have talked about the two methods. We talked about the hydration of ethene, and then we talked about the fermentation fermentation of sugars. So those are the two methods. And then we talked about what? We talked about the differences between the two. Which one is the best, which one is expensive, which one is cheaper, and so on. So that is what you need to remember. Thank you so much for the lesson. We hope to see you in the next lesson. Have a good day and stay safe.